Good morning, children. Today let us see the chapter 6 Statistics. Here the learning objectives are to recall the formation of frequency tables, to construct simple pie charts for the given data, to know how to draw histogram and frequency polygon for group data. Before we learn on pie charts, histograms and frequency polygons, let us recall what we have studied in the previous classes like data and frequency tables for ungrouped data. First, we will see data. Data is a collection of facts such as numbers, words, measurements and observations. For example, staff's age in a company given as 27, 51, 19, 21, 46, 35, 52, 25, 57 and 29. Here the data in the form of numbers. Next one, there are two types of data, primary data and secondary data. First of all, we will see about primary data. These are the data that are collected in person for the first time for a specific purpose at the time the data collected. For example, census in a village, collection of colors which the students like in a class are some examples of primary data. Next one, secondary data. These are the data that are sourced from some places that has originally collected it. This kind of data has already been collected by some other persons. The statistical operation may have been performed on them already. Already some data collected. For some another reason, we may use that collected data. So these data are called as secondary data. For example, the details of patta for a land can be had from the registration office. Birth, death details data can be got from concerned office or some examples of secondary data. Next one, range. The difference between the largest and the smallest values of the data given is range. For example, suppose you consider the data given 5, 15, 10, 7, 20, 18. First of all, we will know what is the greater value 20 and the smaller value 5. Range is equal to difference between 20 and 5. 20 minus 5 gives 15. Next one, frequency distribution. A frequency distribution is the arrangement of the given data in the form of the table showing frequency with which each variable occurs. There are two types of distribution table, namely frequency distribution table for ungrouped data and frequency distribution table for group data. Let us see construction of frequency distribution table for ungrouped data. First of all, we will see ungrouped data or discrete data. An ungrouped data can assume only whole numbers and exact measurement. These are the data that cannot have a range of values. A usual way to represent this is by using bar graphs. Later we will see bar graphs. For example, number of teachers in a school and number of players in a game. Next one. One example we will see, form an ungrouped frequency distribution table for the weight of 25 students in standard 4 given below and answer the following questions. What are the given weights? 25, 24, 20, 25, 16, 15, 18, 20, 25, 16, 20, 16, 15, 18, 25, 16, 24, 18, 25, 15, 27, 20, 20, 27, 25. And the questions are, find the range of the weights. Second one, how many of the students are the highest weight in the class? Third one, what is the weight to which more number of students belong to? And the fourth question, how many of them belong to the least weight? First of all, let us form the frequency distribution table. So the columns are weight, tally marks and frequency. First weight 15. 15 occurs how many times? 3 times. So 3 vertical lines. Frequency 3. Second weight 16. 16 occurs 4 times. So 4 vertical lines in tally marks. So frequency 4. Next one weight 18. 18 occurs 3 times. So 3 vertical lines in tally marks. Frequency 3. Next weight 20. 20 occurs 5 times. So first 4 lines vertical lines and the fifth counting is slanting line. So the frequency is 5. Next weight 24. Tally marks 1, 2. Since 24 occurs 2 times. So 2 vertical lines. Frequency 2. Next one weight is 25. 25 occurs 6 times. Therefore the tally marks first 4 lines vertical lines, fifth one slanting line and sixth one another one vertical line. Next 27. 27 occurs 2 times. So 2 vertical line in the tally marks. Frequency 2. Now count all the frequency. Total will give total number of students 25. Next we will see the answers for the given questions. First of all we will see what is the least weight? 15. What is the highest weight? 27. And what is the more number of weight? 25. And the least weight? 15. Okay, now let us see the answers. First question, find the range of the weights. Range equal to difference between the largest value and the smallest value. So 27 minus 15 gives 12. Second question, how many of the students has the highest weight? What is the highest weight? 27. How many students? 2. From this table, 2 of the students have the highest weight of 27 kg. What is the third question? What is the weight to which more number of students belongs to? More number of students? 6 corresponds the weight 25. So your answer 6 students belongs to 25 kg weight. Next fourth one. How many of them belong to the least weight? What is the least weight? 15. How many students? 3. 3 students belong to the least weight of 15 kg. Understood children? Next one. Let us see construction of frequency distribution table for grouped data. First of all we will see about group data or continuous data. A group data is any value within a certain interval. The data can take values between certain range with the highest and the lowest value. Continuous data can be tabulated in what is called as frequency distribution. They can be graphically represented using histograms. Later we will see histograms. Now, first you see class interval and class size. The range of the variable is grouped into number of classes and each group is known as class interval. How will we write class interval? Lower limit hyphen upper limit. The difference between the upper limit and the lower limit of the class is known as class size. Next one. While distributing the frequency, we follow the counting as given below. Suppose the classes are 10 to 20, 20 to 30, 30 to 40, 40 to 50 and so on. This represents a continuous series. Here 20 is included in the class 20 to 30 and 30 is included in the class 30 to 40. Likewise for the other classes also. In case the given series has a gap between the limits of any two adjacent classes, this gap may be filled up by extending the two limits of each class by taking half of the value of the gap. Half of the gap is called as the adjustment factor. Next one, for example, you see the given one discontinuous series, we will make that as continuous series by subtracting half of the gap from the lower limit and add half of the gap to the upper limit. So it becomes 11 to 20 becomes 10.5 to 20.5. 11 subtracted 0.5, 20 added 0.5. 21 subtracted 0.5, 30 added 0.5. So it gives 20.5 to 30.5. Next one, 31 subtracted 0.5, 40 added 0.5. So it becomes 30.5 to 40.5. 41 subtracted 0.5 and 50 added 0.5. So it becomes 40.5 to 50.5. Next one, inclusive series. In the class intervals, if the upper limit and lower limit are included in that class interval, then it is called inclusive series. For example, 11 to 20, 21 to 30, 31 to 40, 41 to 50, etc. is an inclusive series. How? The data 11 and 20 are included in the class 11 to 20 and so on. Clearly, it is a discontinuous series. So, inclusive series means discontinuous series. Next one, exclusive series. In the class intervals, if the upper limit of one class interval is the lower limit of the next class interval, then it is called exclusive series. For example, 10 to 15, 15 to 20, 20 to 25, 25 to 30, etc. is an exclusive series. Here 15 is included in the class 15 to 20, but 20 is included in the class 20 to 30. So clearly it is a continuous series. Next one, construction of grouped frequency distribution table to continuous series. Example 6.2. The EB bill in rupees of each of the 26 houses in a village are given below. Construct the frequency table. So these are the given data. First you find the maximum bill amount, that is rupees 800, and minimum bill amount rupees 120. First you find the range. Range equal to largest value minus smallest value. 800 minus 120 gives 680. Suppose if we want to take the class size as 100, then the number of possible class intervals is equal to range by class size. That is 680 by 100. We get 6.8. It is nearest to 7. So we will get 7 possible class intervals. So first we will see the class intervals. 100 to 200, 200 to 300, 300 to 400, 400 to 500, 500 to 600, 600 to 700 and 700 to 800. Now the values between 100 and 200 occurs 3 times. So frequency is 3. The value between 200 and 300 occurs 6 times. So frequency is 6. The value between 300 and 400 occurs 6 times. The value between 400 and 500 become 2. The value between 500 and 600 occurs 2. Then the value between 600 and 700 becomes 3. And the value between 700 and 800 occurs 4 times. So totally we get 26. Next one, construction of grouped frequency distribution table for discontinuous series. See, here the frequency will be the same, but the class interval only will be changed as continuous series. 0 to 5, 6 to 11, 12 to 17, 18 to 23, 24 to 29. See, first class interval upper limit 5, second class interval lower limit 6. So the gap is 1. So half of the gap 0.5. So lower limit and all subtracted to 0.5 and upper limit and all added to 0.5. So it becomes minus 0.5 to 5.5. Then 5.5 to 11.5. 11.5 to 17.5. 17.5 to 23.5. 23.5 to 29.5. Frequency no change. Same only will occur. Okay children, revise up to this. If you have any doubt means ask with the concerned teachers. Okay children, thank you.